Alright, so yesterday we talked about combining radicals and doing all of the operations except for division, which is kind of similar to how we talked about complex numbers as well. So today we're going to be talking about dividing radicals. Again, we're going to keep our coefficients and our radicals separate. So whatever the coefficient is out front, those get divided, and then if we can, we divide the radicands underneath the radical. And if not, we do what's called rationalizing the denominator so that no radical remains in the denominator, similar to what we did with complex numbers a couple days ago. So here, in this first example, we've got the square root of 56 over the square root of 7. In this case, we just divide both numbers underneath the radical, and we get the square root of 8. We break that down, and so our final answer is 2 square root of 2. We have another example here where we've got numbers on the outside of the radical and numbers underneath. So 3 over 2 is in its simplest form. That's going to stay. But then we have the square root of 48 over the square root of 3, which becomes the square root of 16 when we divide it. We all know that 16 is a perfect square, so we're going to simplify. We have 3 times 4 over 2, so 12 divided by 2 gives me a final answer of 6. Lastly, we have 5 square root of 72 over 2 square root of 73. Here, 5 over 2 again is in simplest form, so we leave it. And we have the square root of 72 over the square root of 3, which is the square root of 24. That is not in simplest form, so we go ahead and break that down. You can use 12 and 2, 6 and 4, however you want to do it. So I have a pair of 2's, a 6 underneath the radical, so 5 times 2 is going to be 10 square root of 6 over 2, and then 10 divided by 2 is 5. So we have 5 square root of 6 as our final answer. In these next examples, we are going to see 2 that cannot be reduced where the radical goes away in the denominator. So we can reduce them. Square root of 5 over the square root of 10 reduces to the square root of 1 over the square root of 2, which is really nice because now we have smaller numbers to deal with. However, we cannot leave that radical in the denominator. So in order to rationalize, we multiply the numerator and the denominator by the radical that's on the bottom. So we have the square root of 1 times the square root of 2, that is just the square root of 2, and then square root of 2 times the square root of 2, remember we talked about how the radical just goes away, so we're left with 2. The same thing is true with this next example. We have the square root of 12 over the square root of 30. We reduce that. They both divide by 6. So we've got the square root of 2 over the square root of 5. That's not going to go anywhere, so we have to multiply by the square root of 5 to the top and the bottom. And we've got the square root of 10 up top, and then square root of 5 times the square root of 5 just becomes 5. Since one of these is under a radical and the other is not, this number does not simplify. So we leave that as the square root of 10 over 5 for our final answer. Here we see a couple of examples that, when we look to reduce them, are already in simplest form. So in this first one, we're just going to go ahead and take times the square root of 7 to the numerator and the denominator. And so we've got the square root of 42 on top now over 7 in the denominator. Now, notice that 42 breaks down into this 7 and 6 when you factor it out, and it will not pair off with any other values, so the square root of 42 over 7 is our final answer. In this next example, we throw in some coefficients. So 2 over 5 is in simplest form. Square root of 5, square root of 3 is also in simplest form. So when we go to multiply, we only multiply by the radical. So multiply by the square root of 3, multiply by the square root of 3, and we've got 2 square root of 15 over square root of 3 times square root of 3 is just 3, and then 5 times 3 is 15. We double check to make sure that this is still in simplest form, and we've got that 2 over 15, and it is, so then we know this is our final answer. Lastly, we have 3 over the square root of 12. So we don't reduce anything, which means we're going to have to multiply square root of 12 to rationalize. So we've got 3 square root of 12 over 12. Now, 3 over 12 will reduce, so you can go ahead and reduce that if you want to, or you can start by simplifying the square root of 12. Either way is going to land you with the same answer in the end. So if I come over here and break down 12, I've got 4 and 3, 2 and 2, so there's my pair of 2's, comes to the outside, so I've got 6 square root of 3, still a 12 on the bottom. Now my 6 and 12 will reduce, so I have 1/2, which makes my final answer a square root of 3 over 2. Okay, start making things a little bit more complicated here by throwing in some additional numbers in the numerator. Here, we see that the square root of 14 is not going to be simplified, so we do have to rationalize. And when we do that, it's going back to what you guys learned yesterday about multiplying something on the outside by a radical. And so we just distribute. 5 times the square root of 14 is 5 radical 14. Then we have square root of 3 times the square root of 14, which is the square root of 42. And in the denominator, we have 14. You do want to check to make sure that these two radicals up top can't be simplified to the same thing in order to combine them. But if we look at 14, it breaks down into 7 and 2. That doesn't go anywhere. 42 breaks down into 7 and 6. Also doesn't go anywhere. So this is going to be our final answer. With this next example, same thing as what we talked about before. That 2 is there, but it's okay to stay there. We can have a real number in the denominator, just not a radical. So we're going to multiply by the square root of 18, multiply by the square root of 18, so that's going to get distributed. We've got 2 square root of 18, and then plus 5 square root of 54 over 2 times 18. Which is going to simplify to 36. Now here's where we have a little bit more extensive of a process, because as you can see, some of these are going to simplify. So looking at radical 18. 18 breaks down into 1 and 2, and then 3 and 3. So those pair off. It's going to come over here with this 2 that was already there, and then a 2 is going to be left underneath. So we have 6 square root of 2 from that part. Then we've got 54. So if we want to break down our 54, breaks down into 9 and 6, 3 and 3, 3 and 2. So 3 comes to the outside. There was already a 5 on the outside, so 3 times 5 is going to be 15. And underneath the radical, we have a square root of 6. So we're going to add those two things together. That is all still over 36. And then we check to see if we can simplify anything. In this case, the radicals are not the same, so we cannot add. But looking at the coefficients, we have 6, 15, and 36. Those are all divisible by a factor of 3. So 6 divided by 3 is 2 square root of 2. 15 divided by 3 is going to be 5 square root of 6. And then 36 divided by 3 is going to leave us with 12 in the denominator. Okay, so adding in one last little twist here. We now have addition, or could be sometimes subtraction, in the denominator. In this case, similar to what we did again with dividing complex numbers, we are going to multiply by the conjugate. Remember, the conjugate means that I only change this sign that's in the middle. So even though it's a -4, it stays a -4. I'm going to multiply on the top and bottom by -4 minus the square root of 3. And I have -4 minus the square root of 3 down here. When you multiply, now since we have two terms, we have to FOIL in the denominator. So -4 times -4 is going to be a positive 16. We've got -4 times a negative square root of 3, which is going to be 4 square root of 3, and then -4 times square root of 3 is -4 square root of 3. As you can see, those middle terms are just going to cancel each other out, which is how we get rid of the radical in the denominator. Then we have square root of 3 times a negative square root of 3, so it's just going to be 3, and over here we have 16 minus 3. Up top we distribute, so 3 times -4 is -12, and then 3 times negative square root of 3 is -3 square root of 3. And in this case we just need to simplify, so -12 minus 3, radical 3, over 13 is my final answer. So I'm going to give you just a minute. I would like for you to practice with this one. Remember, only changing the sign in the middle to multiply by the conjugate. Alright, so when we multiply, you can see the work shown over here if you need to look back at that later. But I come up with 9 square root of 2 minus 9 square root of 5 over 18 minus 45. That gives me a -27. Now I look at each of the coefficients. They all are divisible by 9. And just so that we can kind of keep it more conventional and leave the negative on top instead of negative in the denominator of our fraction, when we divide, we put our negative up here, so -1/3. And then this is going to be a positive, since it's a negative divided by a negative. So we've got positive 1/3 over here. My final answer is negative square root of 2 plus square root of 5 over 3. And lastly, we have a couple of examples here where we have to FOIL in the numerator and the denominator. So here we multiply by the conjugate, 4 plus 2 square root of 5. Up top, 4 plus 2 square root of 5. And we FOIL. So we have a -20 minus 10 square root of 5 plus 4 square root of 5 plus and 10. And in the denominator, we have a 16. Middle terms cancel out. Our last terms give us a -20. So now we can combine some like terms. -20 plus 10, so it's a -10. And then -10 plus 4 is a -6 square root of 5, all over 16 minus 20, which is going to be a -4. Then we can reduce. So 10, 4, and 6 all divide by 2. And those negatives will cancel out, so we've got a positive 5 plus 3 square root of 5 over 2 as our final answer. Okay, so I'm going to let you guys do this next one again, and then we will look at the final answer together. Alright, so we multiplied by our conjugate, just change the sign in between. When we FOIL the top part, we're left with 12, 4 radical 3, 9 radical 2, and 3 radical 6. Unfortunately, none of those are like terms, so they don't combine. And so all we have to do is simplify the bottom part, and we have all of that in the numerator over 9 minus 3, which gives us 6. And that is going to wrap up our discussion on dividing radicals today.